In this video, we're going to test differences between two population means using t-test from 8.2. The Pet Association claims that the mean annual cost of food for dogs and cats are the same. The results for the samples for the two types of pets are shown below in this table. At the alpha equals 0.05 or 5% level of significance, can you reject the Pet Association's claim? Assume that the population variances are equal. It's going to be important. That's going to tell us how to find our degrees of freedom in this problem. Assume that the samples are random and independent, and that the populations are normally distributed. Complete parts A through E. So I've already put the data in here for our test, for our two sample t-test. And because the population variances are equal, we're going to say yes for this question about pooled or not. So we have 253 for x1, x bar 1, 31 for s1, 19 for n1, 230 for x bar 2, 27 for s2, and 18 for n2. And our test is going to be that they are different for HA because the claim actually is H naught, the null hypothesis that says that the mean annual cost for foods for dogs and cats is equal. So the null hypothesis is going to be an equal sign. The alternative is going to be a not equal sign. And the null hypothesis contains the claim. The rejection region is going to be here, and I'm going to need to look for the degrees of freedom here. Let me just show you. This is going to calculate degrees of freedom for us. DF is going to be 35. I agree with that because 19 plus 18 is 37, minus 2 is 35. So we come down to 35 here, and over to alpha is 5% for a two-tailed test. Third column, so that's 2.030. I'm supposed to round to two decimal places, so 2.03, positive 2.03. Let's look at that. T-value that was calculated is 2.40. So we have negative 2.03, positive 2.03. I'm over here at 2.40. So yes, I'm going to reject the null hypothesis. Because the test statistic is in one of the rejection regions. So at the 5% level of significance, there is enough evidence to reject the claim that annual food costs for dogs is the same as the mean annual cost of food for cats. Let's move on here. The researcher claims that the stomachs of blue crabs from location A contain more fish than the stomachs of blue crabs from location B. The stomach contents of a sample of 15 blue crabs from location A. It contains a mean value of 199 milligrams of fish and a standard deviation of 39 milligrams of fish. stomach contents of a sample of 11 blue crabs from location B contains a mean value of 183 milligrams of fish and a standard deviation of 42 milligrams. Alpha is going to be 10%. We support the researcher's claim that mu A is greater than mu B, or mu 1 minus mu 2 is going to be greater than 0. So that's going to be A here. My claim is here. All right. So let's go ahead and type all this in. Stat test number 4. Our data here is, and we're going to assume again that the population variances are equal here. We're talking about blue crabs, so that should be equal. So 199, 39, 15, 183, 42, and 11. And we're going to say that mu1 greater than mu2 is our HA, and yes, they're from the same pool. That sigma 1 is basically sigma 2. Go into calculate here, and the standardized test statistic is going to be 1.00. Our p-value here is 0.16. We can go out to 4 decimal places if we need to. Let me make sure I'm not accidentally in. Oh, I did. Let me put this back to float. Let's run this test again. That's better. So 3 decimal places. 1, 2, 3 decimal places, and then 3, 5 is 4 decimal places. And so because P is greater than alpha, that means that we're going to fail to reject H naught. And our claim is in HA, so there is not enough evidence to support the claim at the 10% level of significance. Let's move on to the next question. A personnel director in a particular state claims that the mean annual income is greater in one of the state's counties, County A, than in another county, County B. So mu A greater than mu B. In County A, a random sample of 17 residents has a mean annual income of $40,100 and a standard deviation of $8,400. And in County B, a random sample of 8 residents has a mean annual income of $38,900. and SB is 5,900. Alpha equals 0.05. And assume that the populations are not equal this time. So stat test number 4, X bar 1 is 40,100. Then we have 8,400 for our standard deviation, 17 for our number of people sampled, 38,900 for County B, 5,900 for our standard deviation, and 8 people for our sample size. And we're trying to show A greater than B here. And are they pooled? They are not this time, since their standard deviations are not equal. We're going to calculate here, and we're going to get that our degrees of freedom here would be the smaller of the 2 here minus 1, so that's going to be 7. Is what I'm going to look for. The mean annual income in County A is greater than in County B is our claim. And we're going to use the null hypothesis is mu one less than or equal to mu2, and the alternative hypothesis is mu1 greater than mu2, or mu A, mu B. So mu1 less than or equal to mu2, and then mu1 greater than mu2. The alternative hypothesis has the claim. Critical value here, let's just look over here that our degrees of freedom should be 7 for a one tail to the right, and alpha was 5%. So one tail 5%. Critical Z value should be 1.895. And rejection region is going to be T greater than my critical T value there. My test statistic here is 0.412, which is going to be less than. So we have here's 1.8. What was that? 1.895. It's a 995. Critical region over here, rejection region that is, and we are over here for my test statistic that T equals 0.412. So we are going to fail to reject the null hypothesis. And there is not enough evidence to support the claim. The claim was in HA. We did not reject H0. So not enough evidence to support the claim. All right, that's it for this video. We'll come back next time and start talking about 8.3. See you for the next video.